Welcome back, guys. In our last video we talked about strength of material. We talked about chapter 1, the analysis, how to analyze the stress on a member. In the general case, we said something about two members. When two members are joined together with either a glue or nailed together, how to analyze them. Then here we have chapter 2. We will be talking about strain and stress that are under axial load. When we have here, we will be talking about when we have a member and we apply the force is applied. We'll be talking about the deformation of the member. When you have a member and you try to stretch the member will add length. There will be an addition of length on the member, and we call it the deformation of the member. And that is what we are going to discuss about in this video. From the introduction, we derived the formula for the deformation. We said the force in the member, the length, the area, and the Young modulus. This is the length of the member. This is the Young modulus. Young's modulus. This is the area, and this is the force in the member. When you have this, the force, you have the length, you have the area, and you have the Young modulus, you can be able to find the deformation of that member. So let's solve one example so you understand. Now we have a member like this that looks like a cylinder. This is an example. We said the length is maybe 5 millimeter, and the diameter is, let's say, 5 millimeter. The diameter, 5 millimeter diameter. So now let's try to solve this, and we know that a force is applied here, P. Now let's try to solve this to find the deformation. I want to try use something to explain. When we have a member like this is a cylindrical member, and a force is applied from the both sides. This member will try to deform from any part of it. It will try to deform, and if much stress is applied, the member will break, to deform, to cut into two. So the deformation part of it, we will try to find out the addition length in any part of the member. So that is what we are trying to do here. Here a force is applied from the both side, and we have the member. We know that the member is 5 millimeter diameter, and the length also. So let's try to find the deformation. There's one thing you must know. In chapter 2, if they ask you to find the deformation of any member, one thing you must know is you must cut the member. Try to cut the member. When you cut the member, you can be able to find the internal force on that member. So if this member is cut from somewhere here, we will have something like this. It's cut from somewhere here. We can be able to find the force here, and this is P. We can be able to find the force. The reason why we cut it is for us to find this force, the force in the internal force on the member. So if we are trying to find the force, now we know the length. Here we know the length we are talking about is the length of the whole member. So we know that the length here is 5 millimeters. Should be equals to using our calculator. Length, our length should be in meter, not in millimeter. So for example, if you have anything, the length in millimeter, you have to convert it to meter. So by dividing it with 1000. So let's just, this is 0.005 for instance. So but we can't use this. This is just my idea. We have to use 5 meters, 5 meter length. So let's say our length is 5 meters. Our diameter is 5 millimeters. Now we will try to find the area. We know the Young modulus of steel depending on the type of steel. We have some Young modulus of steel. We have some 2000 gigapascal, and we have some 27 gigapascal, depending on the steel, the type of steel you are given. This thing will be given to you. Depending on the type of steel, it will be given to you. So the area, we were trying to find the area by, we know the area, and we said the area of a cylinder is pi, diameter squared, over 4. So we know what is pi multiplied by, we know our diameter, we said our diameter is 5 squared over 4. So we are trying to find the area. We know that pi, our formula for area of a cylinder is this. So we put in the values. We know what is diameter is given, squared. So from here we will find our area multiplied by 5 squared over 4. Sorry, over 4. We will have our area 19.6 millimeter cube. So now we have our area here. Now we can put in this. Coming back here, what is our force? Our force is equals to P. So here we will know that taking a summation of F, we are trying to find the force here. We are trying to find the force here, which will be used here. So summation of Fx is equals to 0. So from here we know that F here is equals to P. So our force here is equals to P here. So now let's put the values in our deformation. We know that our deformation formula is force, length, area, and Young modulus. So here we said that from here we know that our force is P times the length is 5 all over the area we found as 19.6 millimeter to the 2 times Young modulus. We will try to use 200 gigapascal, which is 200 Newton per millimeter squared. So from here we know we found our F at P. So let's say that our P is given to be given, let's say it's 20 megapascal. So from here we know that it here is 20 Newton per millimeter squared. So if you put 20 here, we will try to find our deformation, which is 20 times 5, 19.6 times 200. Yes, here we have 0.026. Here, what I did here is this. We have this. We solve for area. We found this. We put in these values. We put what we found in the deformation formula. We put our force. We said the force is given as 20 Newton to 20 megapascal. The length here I said is the length of all the member, all of them. And the area here is the area of the member, whether maybe cylinder or cubic. We know how to find the area of the cylinder and area of cubic of a cube. So this one example, I hope it will help you. Let me try to go through it again. We said from the introduction we derived this formula, which we'll be using in this chapter 2 mostly. The main reason for this chapter 2 is to find the deformation after you apply a force on a member. The force will extend a little bit. So we were trying to find, let's say this is a member and the force is applied. If a force is applied, we will have something like this. This is the normal length, then additional length. There will be an additional length. So we are trying to find the additional length of the member. So that is the idea of this chapter 2. So we derived a formula, then trying to solve one example. We are given this cylindrical shape member with length 5 meters and diameter 5 millimeter diameter. So the first thing you must know is you must cut it to find the force. So when you cut it, you find the force. Then try to analyze it. You have the length, you have the diameter, you have the Young modulus. Then find the area using the formula for finding the area. We found it here. Then put in the values here: the force, the length, the area, and the Young modulus. We found this. Note that this Young modulus, we are saying, must not exceed 1. It mustn't reach 1. It should be 0 point something. To not pass 1. If you after solving you find 1 or 1 point something, it's wrong. You have to go back and find your mistake. It should be 0 point something. It mustn't reach 1. So that is the idea. In the next video, I will try to solve one more example to make you understand a little bit more. Thank you for watching. See you in the next video.